Hello guys. Today we will be solving CSES introductory problem set problem mix grid construction. Mix refers to maximum minimum excluded number, and excluded number is a non-negative integer. Okay, so let's go by the problem statement. It states that your task is to construct in cross and grid where each square has the smallest non-negative integer that does not appear to the left on the same row or above the same column, and they have given input n and we have to print a grid. So let's go by this example and understand what exactly MEX grid refers to. Right. So in this example, for index 0, the answer, there is no element on the left side of it or above it, so the answer would be 0. And for 1, there is only one element above left side of it, which is 0, and above it doesn't have. So after 0, the minimum non-negative number is 1. And for 2, uh, we have the set 0 and 1, and the remaining would be 2. And let's take one more example, which is somewhere not in the first row or first column, because we understood. Even here you can see, like, for in this position it doesn't have anything on its left, but it has 0 on its top, so the answer would be 1. And for this, it has 2 in its left and 0 and 1 in its top, so 0, 1 and 2 are gone, so the answer would be 3. Now let's solve the problem. It's a pretty simple. Let's try to get something that's easy to understand and implement whatever we discussed, right? So we'll take our input and we'll create our grid at first with all the values as 0. It's an n cross n, so we are that's pretty much it. Let's print and check how it looks. Zero 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 repeated 5 times. Okay, now let's loop through all row index of n, and sorry, I'm just typing in English, I don't know. And for column index in range n, we'll create a set. Let's call it S1. It will store all the main elements left of the position as well as top of the position. So let's add all the elements that came to its left and its top. So we have to loop for r in range Ri, because we only have to check till that row for each element, right? It's dot add grid of row and our current and all the columns, right? No, for each column, right? And next, for column in range CI, son of a grid of row index and column. Then let's initialize a value x, which will be 0 if x is in our set. Increment x by 1, and then I'm so sorry, I don't know. Okay, and then we'll update our grid of Ri and Ci with x. That's pretty much it. So of Ri in range n for j in range n, print rid of ij with a space at the end, and after each loop let's just do this and check how it would look. So 0 1 2 3 4 1 0 2 3 2 5 4 5 6 7 0 4 5 6 7 0. Yeah, this is the solution. Let's download and submit it and check it is possible. Okay, and here demos, yeah, submitted and accepted. Pretty cool. So it was just a normal implementation problem, and logic was also easy to implement. And that's it for day 4 of solving the problem. Thank you.